Hello everyone, section 5.4, equilateral and isosceles triangles. Example 1. In the figure, angle A is congruent to angle B. That makes this an isosceles triangle, but even without knowing it's an isosceles triangle, the base angles theorem applies, or the converse of the base angles theorem in this case. Since we have two angles congruent, the sides opposite them must be congruent, so therefore side AC has to be congruent to side BC. Example 2. Find the value of x. Since we see that all three of these sides are congruent, by the base angles theorem, all three angles are going to end up being congruent, corollary to the base angles theorem. Therefore, this is an equilateral triangle, and each angle must be 60 degrees. So the measure of angle R equals 60 degrees for 2x equals 60, x equals 30. Example 3. Find the values of x and y. So let's go, I'm actually going to go for y first. It's easier to find the value of y. Because, again, equiangular, by the converse of the corollary to the converse of the base angles theorem, means that it's equilateral. So if this is 28, then 4y equals 28. Therefore, y equals 7. Because this is equilateral, this is 28 here as well, which makes this triangle up here isosceles. And since it's isosceles by the base angles theorem, the two base angles must be the same. And since this is 60, this angle here is 120 degrees, which gives me 60 degrees to split evenly between these two. So 2x has to equal 30 degrees. X equals 15. And there's our second answer. Example 4 is actually a preview of a section that we're going to be doing soon. Because we do this chapter slightly out of order, the book assumes that you know the side angle side theorem. If you don't worry about it. That's fine. You're going to learn it in the very near future in an upcoming section. When we do sections 5.3, 5.5, and 5.6 together. But I'd like to do sections 5.4 before that, because 5.3, 5.5, 5.6 use the base angles theorem, the converse of the base angles theorem, to do a lot of the proofs. So I'm just going to treat this as a preview. So explain how to prove triangle PQT is congruent to triangle SRT. So PT is congruent to ST. That means triangle PTS is isosceles, and by the base angles theorem, angle P is congruent to angle S. PQ is congruent to SR, and therefore triangle PQT is congruent to triangle SRT by side, angle, side. And again, side, angle, side. This is something that will become very clear to you in the next unit. Don't worry about understanding it now. It's a preview. Explain why triangle QRT is isosceles. Now that we've got these two triangles congruent, all the other pieces that we didn't know were congruent already must now be congruent. So QT has to be congruent to RT, making triangle QRT isosceles. And that's something, again, in section 5.6 called CPCTC. Corresponding parts of congruent triangles are congruent. And again, that's going to be coming up in the next unit. All right. Example 5. To do example 5, I'm going to do it on the back of this paper here. So we're going to write proof. We're given that angle 4 is congruent to angle 7. Angle 4 congruent to angle 7 here. And angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3. Okay. Our goal is to prove the triangle ABC is isosceles. Okay. We have two angles of two triangles. Sorry about that. We have two angles from two triangles congruent to each other. So by the third angles theorem, angle B has to be congruent to angle C. So let me start writing this up. Example 5. Statements, reasons. 1. Rewriting the given information. Again, I can write squigglies, you can't. When you get a college degree, then you can start writing squigglies. Until then, you have to rewrite all the given information. Statement 2. Angle B is congruent to angle C. Third angles theorem. Now that we have angle B congruent to angle C, now we can say side AB is congruent to side AC, converse of the base angles theorem. Statement 3, AB congruent to AC, converse the base angles theorem. And now that we've got AB congruent to AC, statement 4, triangle ABC is isosceles. Definition of isosceles triangle. QED. Example 6. Line J is parallel to line K. You can see that's actually marked in the diagram already. AB is congruent to CB. That's a little harder to mark. You just kind of have to remember that AB is congruent to CB. Our goal is to prove that angle 1 is congruent to angle 2. Okay, so I'm going to take off the paper. Example 6. Statements, reasons. This one's a little bit longer. 1. Rewrite the given. 2. Since AB is congruent to BC, angle A has to be congruent to angle C. Base angles theorem. Since angle A is here and angle 1 is here, and line J is parallel to line K, angle 1 has to be congruent to angle A. Angle 1 congruent to angle A. Also, angle 2 congruent to angle C for the same reason, and that reason is corresponding angles theorem. Angle 1 is congruent to angle A, angle A is congruent to angle C, and angle 2 is congruent to angle C. And angle 1 congruent to angle 2, transitive property. Angle 1 is congruent to angle 2. Measure of angle 1 is equal to the measure of angle 2. Definition of congruent angles. Okay. Example 7. BC is congruent to AC. If angle 1 is 140, then the measure of angle 2 will be 40 degrees. Triangle ABC is isosceles. Angles 3 plus 4 have to equal 140. They also have to be equal to each other, so each one is 70. Okay, part B, if we change the given information, except we're still keeping BC congruent to AC. That stays given. Now, angle 4 is 65 degrees. That makes angle 3 65 degrees. Angle 3 plus angle 4, 120, 130 degrees. That makes angle 1 130 degrees. And angle 2, 50 degrees. There's example 7. Example 8. WX is congruent to XY, which is congruent to YZ. That makes 1 congruent to 2, 3 congruent to 4. Okay, if angle 1 is 20 degrees, then angle 2 is 20 degrees. That makes this unnamed angle, angle XYZ, 140 degrees. If this is 140 degrees, then this angle here is 40 degrees. There's angle 3. Angle 4 is the same as angle 3, 40 degrees. 40 plus 40 is 80. That makes this 100 degrees. 120, 100 plus 20, that makes angle 5, 60 degrees. Okay. What's the relationship between angle 1 and 3? We can actually get this by looking at part A. What's the relationship between 20 and 40? This is equal to 2x. Angles 3 and 4 are the same, so this is also 2x. What's the relationship between angle 1 and angle 5? 3x. And we can go through it the exact same way that I went through it for part A, but it's quicker to do it this way. All right, last two examples. Example 9. Solve for x and y. Triangle ABC is equiangular. And let's draw a picture. AB, if it's equiangular, then it's equilateral. AB is 4x minus y. BC is 2x plus 3y. And AC is 7. So we're going to write out two sets of equations. We're going to write 4x minus y equals 7. We're also going to write 2x plus 3y equals 7. AB has to equal to AC. BC has to equal to AC. So there are my two equations. I now have a system of two equations and two unknowns. So we have to solve these equations. We could solve them by substitution. I'm actually going to do elimination, probably because you haven't seen it in a long time. Substitution would be pretty quick. I would solve this for y, and I would substitute that back in to see what I get. Actually, I changed my mind. I'm going to do that because on the answer key, I solved this by elimination. I eliminated the x variables. I multiplied the second equation by -2. That cancels the x values, and I get my answer. So you can follow that to see how I've done elimination. Let's do substitution. I'm going to change this equation, y equals 4x minus 7. Solving that equation for y. Plug this in for y in the second equation. 2x plus 3 times 4x minus 7 equals 7. 2x plus 12y. 12x minus 21 equals 7. 14x equals 28, x equals 2. It's one of my answers. Take this, plug this back in for x up here. I've already got y solved for. 7. Y equals 8 minus 7. Y equals 1. And there are my two answers for the values of x and y. All right. B. Again, we have an equilateral triangle. Since we have an equilateral triangle, then it is equiangular. Since it's equiangular, all three angles have to equal 60 degrees. Since all three angles equal 60, then x plus y equals 60. And 2x minus y equals 60. This one, did I do it by substitution over here? Nope, I did elimination again. If you just add these two equations together, the y values are going to cancel. And elimination is actually much quicker in this particular problem. So I'm going to use substitution just so that you see how to do it. Subtract x from both sides. Y equals 60 minus x. 2x minus 60 minus x equals 60. 2x plus 60 plus x equals 60. 3x equals, minus 60 here. Equals 120. X equals 40. Plug that in here. Y equals 60 minus 40. Y equals 20. And there are my two answers, and I got these again by using substitution. If you want to see the elimination method, it's in the answer key. All right. Example 10, last example in these notes. For the points 0, 0, and 5, 5, there are 6 points that could be the third vertex of an isosceles right triangle. Find the coordinates of each. So we have 0, 0, 5, 5. So what other coordinates could make an isosceles triangle? Well, isosceles right triangle. We could have one here at 5, 0. That would make a right triangle, isosceles right triangle here. 0, 5 would make a right triangle up here, isosceles right triangle, where these two sides would be the same. They would each be 5.
Sorry, I'm not sure about that.
And we could go, this one's a little bit trickier. 5, -5. And this triangle would be right here, making it isosceles right there. I could go -5, 5. Making a right triangle here. This one also is a little bit harder to see. Right out here. Ten, 0, or 0, 10. And there are these 6 points that could be used for the third vertex, making an isosceles right triangle. Again, not just isosceles, but also right angle here and here. That's 45. That's 45. Okay? Thank you.